fun, but I have another one millennial story to tell you. All right. So obviously we know I equals the square root of negative 1. Do you guys remember what I squared is? Negative 1. So we've got I is just I squared is negative 1. I cubed, do you remember what that is? Negative I, very good. The logic with this now follows exponent rules, right? I cubed is the same thing as I times I squared. And I squared is negative 1, so negative 1 times I makes negative I. I to the 4th is 1. Logically, that's because that's I squared times I squared from your exponent rules, which is negative 1 times negative 1, which is 1. And what's I to the 5th? There's I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. What's I to the 5th? Just I, exactly. This cycle just now is going to repeat. I to the 5th, I to the 6th, I to the 7th, I to the 8th. 9th, 10th, 11th, 12th. 13th, 14th, 15th, 16th. What's important is that any I to any multiple of 4 is just 1. So when someone asks you, what is I to the 203rd power? Your job is to figure out, well, what is the closest multiple of 4 that is less than or equal to 203? Abby? What's the closest multiple of 4 to 203? Joe? What? 50. 50 is very far away from 203. It's either got to be 202, 201, 200, or 199. 200, right? So we would split this up, thinking exponent rules, into I to the 200th times I to the 3rd. Because any multiple of 4, i.e. the I to the 200th power, is just 1. So this is going to simplify down to whatever I to the 3rd is, which you should have memorized, which is negative I. Did you do this last year? You did. Maybe not a lot. Well, Connor thinks you did. Oh, yeah, you don't have that luxury this year. That's right. I don't even know, like, using my calculator to do one of these problems is just so foreign to me that I, like, forget to teach my Algebra 2 kids that there's that I button on your calculator. Because you should know it. This year I'll make you know it. All right, so that's that situation. Just in here, you all know the imaginary number standard form, a plus bi. The a is the real part, the bi is the imaginary part. And here's just a new vocab word. If I say something is purely imaginary, that means that a is 0. So it's just 7i. That's purely imaginary. But if I give you 5 plus 7i, that's a complex number because it's got that format and it contains an I, but it's not purely imaginary. So just if you ever see that. Simplifying just like we would do with polynomials, we're going to subtract these two binomials. So that involves distributing your negative, minus 12 plus I, and combining like terms, keeping your real part first. So 2 minus 12 is negative 10 plus 7i, and we're done. Exercise 2, multiplication. So we're just going to FOIL. And what happens is we really have 3 types of terms. We have constant, we have I terms that can be combined, and we have an I squared term. But yet, imaginary number standard form should only have 2 types of terms, an I term and a constant. So what you're used to and you should know is that you would simplify your I squared down to that -1 that it is. So a positive 15I squared is going to change to be -15 as a constant. So -14 minus 15, -29. -35I plus 6I is -29I. Don't factor out the -29 because the instructions were to simplify. They were not to factor. Those are two opposite things. How about the next exercise? Can someone first and foremost tell me what's wrong with that expression? Trista? Correct. You can't have an I in the denominator because that's like having the square root of -1 in your denominator, and we can't have radicals in our denominator. So we need to rationalize. And so if we want to get rid of that in the denominator, what would we multiply this by to rationalize? Mackenzie? 2 plus 5i, because that's part of a binomial. We would multiply by its conjugate. Now in the numerator, we can multiply this out by foiling. In our denominator, we want to foil as well. It's just be mindful of the fact that when you're dealing with conjugates, your outer and inner cancel. So you just have 2 times 2, which is 4, and -5i times positive 5i, which is -25i squared. So for those I squareds, that's going to turn the plus 20i squared into a minus 20. It's going to turn the -25i squared into a plus 25. So I'm just going to cross out that I squared and flip the sign. So in my numerator, 14 minus 20, -6, plus 43i all over 29. The next one I have starred because there's an important conversation piece to have here. When we're dealing with radicals and we're multiplying radicals, do we multiply first then simplify, or simplify first then multiply? Anybody know? Andrew? Simplify first, then multiply is correct. If you flip that order here, you're going to get a different answer. Now, normally, it doesn't matter. If negative numbers are not involved and imaginary numbers are not involved, it doesn't matter. I actually tell my kids, and I just did this in Algebra 2 this morning because they don't know about imaginary numbers yet, we're doing radical operations and multiplying. I actually tell them multiply first, then simplify. Reason being, when you're not dealing with imaginary numbers, if you simplify first and then multiply, oftentimes you have to then simplify again, so it just makes it a longer process. So I tell them just multiply first, make these numbers humongous, and then simplify from there. Although I'm holding a little bit of the truth from them because with imaginary numbers you cannot do that. You have to simplify first. So we'd have 5i times 2i, which would be 10i squared, which would be -10. Obviously, if I multiplied first, I'd get the square root of 100, which is just 10. And that would be bad. Okay? So likewise on this one, I really should change this square root of -5 to what? Aiden? Yeah, but we'll put the I in front. If you put it after the fact, it's a little dangerous because then we have to look a little more closely at the length of your radical. Is it over? Is it under? So we'll put that out in front. And I'm going to square this, so I'm just multiplying it by itself. So foiling here. Oops. Any questions on that? Okay, and our next one, how are we going to simplify the square root of negative 50, Nate? Good, and your radical 25 will actually become 5. So 5I root 2. Very good. So negative 25 plus 5I root 2 over 15. And obviously then we can simplify the fact that both terms in the numerator are divisible by 5, as is the denominator. And so we would divide all terms by 5, and we'd simplify it down. Okie doke. I'm nervous. I haven't looked at the back yet. Not since last year. Oh, I know how to do this. So do you. What do you do? Come on, how do I solve this? Bailey?
Didn't you just do like quadratic formula?
Correct. Do you know it?
You said negative b plus or minus square root of b squared minus 4ac over 2a.
Is she right? Good. So the opposite of b here is going to be 2. I like to negate that right off the bat. Plus or minus the square root of. I also like to square b right off the bat, and what's that going to be? 4. And I double a as well to save myself from some time. So I get 2 plus or minus the square root of 4 minus 12 times 4. What's 12 times 4? 48. 4 minus 48. Very good. All over 6. I break down the square root of negative 44 into what? Andrew? Perfect. All over 6. And then all 3 terms are divisible by 2. Good. Any questions? All right, I want you to take the next 5, 7 minutes to do these 6 on your own.